Hey guys, so a few of you have been asking about how HyperDrive can handle high currents. So in this video I'm going to do a quick demo of the thermals and how it handles the heat generated. So what I have here is a little servo that's hooked up to a servo controller, and that's going to pull the trigger consistently once every second. And I think I'm going to go for a test of 500 rounds. So I have a 16 TPA motor, 13-to-1 SHS gears, and a M120 spring. Most of this gun is pretty stock, or nothing too special about it. So go ahead and plug it in and connect to Wi-Fi. And there we go. Most of these settings are pretty standard. I have 200-degree cutoff angle, 5 milliseconds active braking. Let's see. Total number of shots is 3724. So we will reset the user counter and refresh to update. So now it's at 0. And then we're going to be doing this test on binary. And that will just give a better, because on semi and binary you get higher peak current. So that'll generate more heat than if it's just on full blast on auto. And we have fully charged battery, 4.2 volts. FET temperature is 30 degrees Celsius. And on semi, we're getting just under 100 amps peak and around 55 for average. So I could definitely get it a lot less, but that's not really the point of this build. So with that, I will go ahead and start the test. Alright, so that should be about 500 rounds. So if we go and check the temperature now, you guys can see that the temperature is only at 40 degrees Celsius. I don't know off the top of my head what that is in Fahrenheit, but I think it's around maybe 120 degrees. So as you can see, the motor itself is getting pretty hot. It's hard to hold at this point, so we're nowhere near the thermal cutoff of 70 degrees Celsius. So and that's due to the fact that HyperDrive uses some of the lowest resistance MOSFETs that are currently available. I believe they're about half the resistance of other MOSFETs that are used in other ETUs, and in addition to that, it uses a circuit board that has higher, thicker copper layers, and that means that it can kind of disperse throughout the PCB a lot better. And then also it's able to, that sticky adhesive tape will transfer a lot of the heat that's generated directly to the gearbox shell. And so that's gonna wick away even more of that heat that's generated. So hope that was informative to you guys. And yeah, be sure and like this video, and I will keep posting more updates. Thanks.